Hi, hello, dear students. Welcome to YRK'S chemistry classes, Race Academy, Bangalore. Today my lecture 1 on coordination compounds I am going to start. It is the unit number 9 in our second year syllabus, CBSE, and class 12 syllabus, which is the most important topic when we consider competitive examination corner also. Okay. So in this, we will have a weightage of around 6 marks in the board examination for Karnataka PUC. In various board examinations, coordination compounds has played an important role, we can say. So in this, I would like to speak few things about two important differences of compounds. The first, I am going to talk about addition compounds. Addition compounds. Addition compounds. See, what is addition compounds? Means it's a combination of two or more simple salts. Actually, addition compounds is nothing but they are obtained by crystallization actually in solution. They contain two or more simple salts. So they contain two or more simple salts. Okay. Do remember, from this classification of addition salts, addition compounds, we will be having one kind of compounds that we can also call coordination compounds. In that, the one category is called as double salts. One category is called double salts. The other category is called as complex salts. Complex salts. These complex salts now we are calling as coordination compounds. So another name for complex compounds is coordination compounds. So before going straight away to the coordination compounds, we should know what is addition compounds. Means addition compounds are obtained by the crystallization of salts in solution. There are two types: double salts, simple salts, complex salts. These complex salts can also be called as coordination compounds. Okay, let us talk about the first category, double salts. Earlier we told there are two or more simple salts. For our understanding as per the syllabus, the double salts can be called as molecular compounds. Actually, these are molecular compounds. They only stable in solid state. These are molecular compounds only stable in which state? Solid state only. Solid state only. While in solution, they dissociate into ions. Means in solid state they are stable. They will dissociate into ions in which state? In solution state. In solution, in liquid state. So it is very clear that stability of the double salts in solution is not observed, but stability of the double salts in solid state is observed. Okay. Example, if you talk about different examples, the first two major important examples we have, one is alum. One is alum. It is potassium sulfate, aluminum sulfates mixture. Potassium sulfate is K2SO4, aluminum sulfate is Al2SO4 thrice. Along with that, there are 24 water molecules are there in this alum we have. Similarly, one more most important example we have in the syllabus, that is more salt. More salt. It is again of two kinds, two simple salts mixture. One is ferrous sulfate, another one is ammonium sulfate. Ferrous sulfate is FeSO4. Ammonium sulfate is NH4 twice SO4. Along with it is having 6 water molecules of crystallization. Water of crystallization is 6 water molecules here. So, this is double salts information. What is double salt? These are the molecular compounds. They are only stable in solid state and they dissociate into ions in liquid state called solution state. Examples we have alum, K2SO4, Al2SO4 thrice, 24H2O. More salt, another example for this, that is ferrous sulfate FeSO4, NH4 twice SO4, 6H2O. These are the two examples we have. Let us talk about complex salts. Complex salts. Another name for this one is coordination compounds. So, both the addition compounds what we are discussing, they are called as molecular compounds, which actually these complex compounds, coordination compounds, got advantage compared to double salts is the ions will retain their identity in solid state as well as in solution state in complex compounds. So, another name for this is nothing but complex compounds. So, complex salts in which we have most important point to be noticed is ions are there, the molecules are there, the ions will retain their identity. So, the compounds will retain their identity in solid as well as in liquid state, means liquid state another name is solution state, as well as in solution state. That is what the advantage of complex salts study over double salts. So, what are complex salts? These are also molecular compounds which retain their identity in solid state as well as in solution state, which we will call it as complex compounds or the coordination compounds. The best examples in this one is potassium ferrocyanide. We can take an example, that is K4Fe CN6. This potassium ferrocyanide, if you observe its ionization, it gives 4K plus and one ferrocyanide ion FeCN6 4 minus. So, that is the ion, complex ion. This ion obtained is called as complex ion. These complex ions have different kinds of chemical properties than the constituent ions. So, constituent ions are different. Here to form this K4FeCN6 we have constituent ions, ferrous ions, cyanide ions, K plus ions are required. But when it comes to this complex ion obtained by the ionization, this complex ion behaves differently in chemical properties compared to the constituent ions. So, these ions cannot be tested from their aqueous solution. See, what is the peculiar behavior of this complex ion? This is a complex ion. Is if you try to test cyanide ion or if you try to test ferrous ion using general analysis, they don't give that result. Why? Because is a complex ion is having a separate physical property compared to the constituent ions Fe2 plus ions and Cn minus ions. That's why the interesting study about the complex compounds is nothing but complex compounds containing complex ions gives extra stability to the compounds when compared to the constituent ions in the simple salts. So, simple salts are stable, but compared to simple salts, these addition salts obtained which are called complex salts are more stable. Reason behind that one is these compounds will retain their identity, these ions will retain their identity in solid state as well as in solution state. Okay. This is one very simple idea of the presentation of the introduction of coordination compounds by means of telling about what is addition compound of two types, in that why complex compounds are dominating over the double salts. Okay. Means in lab analysis, cations and anions identification, if you do with the double salts, you will get the positive results. But in complex salts, if you do identification of cations and anions after the formation of this complex ion, it is not going to give that result. Why? Because the entire complex ion has got separate chemical properties compared to that of general cations and anions, which are responsible for the formation of complex salts. Okay. So, this is about the generalization of addition compounds. Let us take some examples in this. Yeah, in this simple cation and complex ion examples I am going to write. I am going to write examples. If you want to write a simple cation and a complex ion, simple cation and a complex ion, then you can take an example like whatever I discussed, potassium salts. Potassium is K4, complex ion is FeCN 6 times, or you can take K2 PtCl6. What is PtCl6? Is platinate. These are the examples of this kind. Means potassium is a simple cation and this square bracket whatever we are showing, that is comes under complex ion. Here potassium K2, 2 potassium are there, and inside the square bracket we have some metals and other groups are there. Okay, we will talk about what are the other groups and all in detail in this discussion. Next, we have a complex ion, a simple anion. We have a complex ion and a simple anion. Complex ion means first we are going to write the square bracket, next we are going to write the anion. So, square bracket we are writing, inside that we are writing copper with 6, or you can write 4 copper coordination number here in this, and sulfate we are writing outside. Similarly, chromium also we have an example with 6 water molecules. and nitrate ions present outside. So first we are writing complex ion. Next we are writing simple anion. So anion is sulfate here. In this example we have anion is nitrate. Okay. This is one type of example. Another example, let us say another kind of example we have. First we are going to complex cation. Next also we are going to write the complex anion. Okay. So complex cation and complex anion. So we are representing a complex compound, means coordination compound, using two square brackets. In this example, platinum with 4 ammoniums, next platinum with 4 chlorines. So this is one complex compound which is obtained by combination of complex cation and complex anion. Likewise, we have cobalt complexes also there. CONH3 6 times, complex cation, COCN 6 times, complex anion. So whatever we are writing, the right side of this formula, that is anion, left side we have cation. First we start with cation, next we will write anion. Another most important example in this case is, here we are writing cation and anion, the first example. Second example we are writing complex cation and simple anion. It's complex cation this is. Okay. So complex ion. So first we are writing complex cation, next we are writing complex anion. In this last example we have neutral complex compounds. Neutral complex compounds means we are not going to differentiate what is anion and what is cation. Okay. In the case, we are going to only write one square bracket without any saying any cation and anion. CONH3 3 times and Cl3 3 times. So outside the square bracket nothing is there. In this example, which complex compound is called as neutral complex compound. Similarly, we have carbonyl compounds are there. Nickel carbonyl NiCO4 times, also a best example for this kind of neutral complexes. So once you start observing the different kinds of examples, understanding that first we have to write cation, next we have to write anion. So the second example we start with the complex cation ending with the simple anion. Third example we start with complex cation, we end with complex anion. So both are complex ions only. But in the fourth example, we are not going to write any kind of anion and cation separately. We are going to write only one square bracket saying it that complex compound is a kind of complex called as neutral complex compound. Okay. So in this discussion, what we have noticed is coordination compounds and their classification has got a vast information in further discussion in complex compound study, and it is interesting also. Okay, let us move to the next one. What is actually the terminology we are going to discuss in this coordination chemistry? Okay, so we will talk about the terminology. Because simply saying that square bracket, this is cation, this is anion, no. So that is one way of initial observation. Now the complex compounds chemistry, complex chemistry is introducing some important terminology and wording to us. So what is that? We will see. Terminology in this coordination chemistry. In this coordination chemistry. In this terminology, first we are going to talk about one important term that is called as coordination entity. Coordination entity. So whatever we are talking about square bracket is there, na? That square bracket information terminology is not square bracket in this complex coordination chemistry. That we will call it as coordination entity, which consists of, actually it contains one central metal. So this coordination entity square bracket contains one central metal, that may be atom or ion. You can say atom or ion. So this inside the square bracket means coordination entity, what are present, that we are talking. So in that central metal, atom may be there or ion may be there, that is bounded to fixed number of molecules. Bounded to fixed number of molecules or ions. So whatever square bracket is there, like if I write an example like CO, NH3, so ammonia are there. If I am taking 3 ammonia, 3 chlorine, then ammonia is molecule, Cl is ion in this formation of this coordination entity. Okay. So coordination entity is consisting of metal ion, central metal ion, here central metal is cobalt, and the molecules or ions are said to be bonded with this coordination central metal. In this, cobalt ion is surrounded by 3 ammonia molecules and 3 chloride ions. Usually we will say chlorine, but this Cl are ions, not atoms. So do remember, this entire whatever the enclosure is there, square bracket, that we will call it as coordination entity. Okay. Hope you understand what is coordination entity. Let us see another example, another terminology, that is central atom or ion. Central atom or ion. So I am talking about central atom here. So what is that central atom? Usually coordination compounds consisting of central metal atom or ion, they all comes from transition metals in the studies, because transition metals have a characteristic property of formation of complex compounds. So major role played by the central metal ion in the properties of complex compounds of transition metals. So this central metal atom is there in the coordination entity, that is a fixed number of ions and or molecules will be bounded to this central metal, okay, in a geometrical arrangement is there. So that geometrical arrangement is because of central metal ion only. Okay. What is the role play of central metal atom? So it will give definitely geometrical arrangement to the complex compound. this gives definite geometrical arrangement to the complex means complex compound. Example, if you take any example like potassium complex K3FeCN6, in this iron is not iron, it is a metal ion. Okay, in this Fe3 plus is there. Fe3 plus is the central metal ion. In this central metal ion, whatever is there, this is bounded to, this is surrounded by this one, there are 6 Cn minus ions are there. Okay, and in this Fe3 plus is requiring some electrons for its stability, so it takes electrons. So whichever takes electrons as per the Lewis acid base theory, they are called as Lewis acids. So what are Lewis acids? The role play of the complex compound coordination chemistry by the central metal atom is behaving like Lewis acids, accepting electrons from the other groups, means molecules or ions which are bounded by this one. So this whatever we are writing next to the central metal group means groups, molecules, atoms, ions, they all try to donate electrons to this central metal atom or ion for stability. This is what we can understand in this one. Next important terminology, the most important terminology in coordination chemistry, that is ligand. So ligand. Just now I told about what is Lewis acid role play. Central metal atom's role play is accepting electrons. So when it is trying to accept electrons, the Cn minus ions are trying to donate electrons. So that is what we understand. So that type of species which are around the central metal atom or ion present in the coordination entity are called as ligand or ligands. So what are ligands? These are, they may be molecules, or they may be ions, or they may be neutral atoms. Okay, in general study we will call they are molecules or ions bound to the central metal atom, bound to the central metal atom or ions which donate electrons, which donate electron pairs in coordination entity, which are called ligands. So what is exactly the important terminology involved in the coordination chemistry of ligands is, these are the molecules or ions bound to the central metal atom or ions which donate electron pairs to the coordination entity, electron pairs in coordination entity. You can ask, what is the reason, what is the necessity for this type of ligands to donate electrons pairs to the central metal atom? Because central metal atoms are unstable and they want electron pairs to reach the next nearest noble gas electronic configuration to make the coordination complex more and more stable. So the reason why is nothing but donating and accepting. Donor and acceptor behavior is one of the important type of chemical bond which is called as the coordination bond between metal atom and ligands. So that is the important complex compound study, we can say the bond involved. So what is the bond involved is day to bond or coordination bond. So between metal and ligand. So metal accepts electrons from ligands. Around the metal, how many ligands are there, that will decides the geometry shape of the complex compound. Okay. So this is about ligands discussion. Still we need to study about more and more about the types of ligands. Then we have to look an eye on the classification of ligands. So let us start that classification types of ligands now. Now I am going to talk about the types of ligands. Types of ligands. As I said earlier, ligands have a tendency of donating pair of electrons to the central metal atom to get stability. Means whatever molecules are there around the central metal, so metal is there, around the metal there are some ligands are there, they are donating electron pairs to the metal. So in donating such type of electron pairs, these ligands are again classified into different kinds. They are also called as some neutral ligands, some cations ligands, anionic ligands, like that. So ligands are classified into anionic ligands. Some are called as cationic ligands, some are called as neutral ligands. So most commonly anionic ligands means negatively charged species whatever are there with some extra electrons. On the basis of that we can say these are anionic. Example I will give F minus, Cl minus, Cn, most common examples F minus, Cl minus, Cn minus, even some of the ions, general ions like thiosulfate ions and oxalate ions, sulfate ions, nitrate ions, etc. all will come. So this comes under anionic ligands. They have some charge, negative charge is there. Cationic ligands. When you talk about cationic ligands, definitely the charge is positive charge, right? So in this we have very few examples of NO plus. Like that we have N2 H4 plus, hydrogenium ion, nitrosonium ion are the examples of this kind, etc. Coming to the neutral ligands, we are already observed, frequently you observed ammonia, water are the best examples of this kind. So we can write NH3, H2O, and sometimes oxides, nitrogen oxides also will come in the discussion. We have NO is also sometimes, rarely in brown ring test and all we used to see, they are neutral. So these are the examples of ligands. So you can go through all these examples. In all these examples, keeping one thing in mind, that these ligands having a capability of donating a pair of electrons. In our initial study, such types of ligands usually we will call monodentate ligands, means they can only donate a single pair of electrons. Okay, we will further divide the types of ligands on the basis of the number of pairs of electrons donated by them to the central metal ion. So the types of ligands on the basis of electron pairs donating capacity. For example, if you say the ligand is a monodentate ligand means that has a capacity of donating only one pair of electrons, that's all. Similarly, when you identified that the ligand is capable of donating two pairs of electrons, you can say that is a bidentate ligand. Bidentate means that can have a capacity of donating two pairs of electrons. Two pairs of electrons. Suppose if you found something more than that, means more than that, if the ligand is donating, then you can call it as polydentate ligand, means more than two electron pairs. Suppose if you identified that exactly the 6 electron pairs are donated by ligand, that you can call it as hexadentate. Specifically, if you know, you can tell, or if it is more than two pairs only, if you know, then you can also call they are polydentate ligands. Example, if you take ammonia can donate one pair of electron, Cl minus, Cn minus. Most of our general examples are comes under this category only. In bidentate ligands, coming to the bidentate ligands, we have one example is there that we can call it as En. We used to call it as En, ethane 1,2 diamine. Its expansion is ethane 1,2 diamine. So in this case, we can able to say that this will comes under bidentate ligand, as it has a tendency of donating two pairs of electrons to the central metal. En, we have to indicate En is a neutral ligand. Like that, oxalate ion is there. Another example, the oxalate ion, we can shortcut, you can use OX. Actually, its complete name is oxalate ion. You know oxalate ion C2O4 2 minus. If that is considered, then that is also one of the bidentate ligand we have. Okay. Coming to the last example, polydentate ligands, we have EDTA is the best example for this one. That is nothing but ethylene diamine tetraacetic acid is a bidentate, is a polydentate ligand. This is ethylene diamine tetraacetate ion. Actually, ethylene diamine is very clear, means you can write ethylene means 2 carbons, remaining is diamine means 2 bonds with NH2 you should write, but these hydrogens are replaced by this acetate ion CH2COO minus, CH2COO minus, here also CH2COO minus, CH2COO minus. These are 4 and these nitrogens are 2, a total of 6. That's why we will call EDTA is hexadentate ligand. Hexadentate ligand. Some other examples we have, tridentate are there, diene is an example for tridentine and all, but most important examples we have observed in this classification. Okay. Okay, dear students, this is what my first presentation or lecture 1 presentation on the coordination compounds introduction. Okay. The next class we will meet in the additional importance of the ligands and other things. Until, have a nice day. Keep watching my videos and subscribing as well as sharing. Don't forget with your friends. Thank you.